Hello students, in this lecture I'll try to explain how we use p-value test with examples. So, as you know, we apply p-value test when we try to reject hypothesis or we try to apply our new hypothesis or then we fail to reject hypothesis or null hypothesis. So we use three examples of tests: is two-tailed test, right-tailed test, or left-tailed test. It will be like that. So if we have distribution of our probability, normal distribution, you see this is the whole, and this is area where our values often lies. This is will be called area of FTR. So this is fail to reject our null hypothesis, and this area AC we will reject this null hypothesis and we accept alternative hypothesis. So this will be if only to the left-tail test, then to the right-tail test, and if we are used of mean value of our samples, then we use two-tailed test. So this is the steps for our hypothesis test. We state our both hypothesis, null hypothesis and alternative hypothesis, and identify clearly the claim. Then we determine which test we use, then find the critical Z value and we sketch the graph and label on it. Then we calculate test statistic and make decision about our null hypothesis. So this is the formula for calculating Z criteria. I see it like this, that it will be with our sample mean and the general mean. General statistics, standard deviation must be known, and with n as sample size. Let's go to the one of our examples. We have claimed that something is in average equal to 75 millimeters, and alternative hypothesis is that is not so, and conditions with our level of significance will be 5%, and we made some, of course, measurements, and we calculate that our sample mean is 74. And standard deviation of this sample and all of population is also known, is 3.1, and our sample is 80, so it's more than 30, and we can use the criteria. Then how we use it. With the statistics in that criteria, we know it that our level of significance was 5% or no pads, and if this is two-tail test, I explain later why it two-tail test, then we have to go as this, and we have that 0.05 divided by 2 because it's two-tail test, and by these values we have the value of 1 and 1.9, and then 0.6 we added, and we have in this Z criteria when we start to sketch graph, so it will be like that. So we have this area and this area minus 1 and 96 driven from table and the same. So this is the area of FTR, fail to reject. If our Z criteria will be in this area, we fail to reject our null hypothesis. But when we trying to calculate and see that our Z value is minus 2 and 0.89, then from this criteria we can calculate that we reject this, of course, because it's something like that, and the probability is less, and our p-value is less than of null hypothesis, so we reject the null hypothesis and we accept the hypothesis that our hypothesis and our mean is not 75 millimeters as we supposed to and was known. So then next example. So we have this data that claims that something has mean of 168 and alternative hypothesis that is not so, and with such conditions we made sketch as usual. See something like that, and we have some Z value and calculate by table, of course the same, because the level of significance is the same, so we have to place here and this area. So you see, this is area of FTR. This is area when we reject our null hypothesis. So by this value we know that it's not true and we reject our null hypothesis. Then we have a right tail test as an example. As you see, we must clearly know the claim. So this is how we use. Something is known as average, like 20. But now we're claiming that it's not 20 and it is more than 20 because we have some data and we have some calculating, and our mean is 23 as you see, and standard deviation is known as h, and our sample size is 36, so it's more than 30, and we use that criteria. So we as usual drawing a sketch. Let's be like this and make our distribution line with probabilities. So with significance level, as you know, it will be like that. So this is, and our criteria will be, after calculation, it's 2 and 0.25. It will be here. So we use right tail test, and see, by this test we reject our null hypothesis. So this lecture is over. See you next time.